Hey guys, this is the end of chapter 12 review, and we're going to be working on some problems throughout different pages. So right now you should be on page 915. Now, if you're watching this, you should have already done number 12, 13, and 14 on your own, and you should be just checking your answer. So in 12, 13, and 14, you had to select an appropriate type of display and then justify your reasoning. So down below here, I have the types of displays and what they're best for. So we'll use that to help us with our answers. So let's start here with number 12. And number 12 says, the amount of sales a company has over 6 months. Now the key is the over 6 months. Because that shows change over time, you would use a line graph. So 12 is line graph. And here's your reasoning. Because a line graph shows change over time. All right, if you had that, good. If not, you could pause it and change it. Let's go to number 3, the prices of 5 different brands of tennis shoes at an athletic store. All right, so your answer for 13 is going to be bar graph. Now, here is why. You are comparing 5 different brands of tennis shoes. So bar graphs are good to show the number of items in specific categories. So those brand of shoes are your categories. So your reasoning is it compares the prices of the shoes or the prices of the categories. All right, and the last one you have to do on this page, it says the amount of savings, the amount in a savings account over a year. So this one also says over a year. So anytime you have time, you know what your answer is going to be. So your answer, again, is going to be a line graph. And here's your justification. It's the same as number 12. It shows change over time. That's what line graphs do. All right, so that's it for page 915. Now, we're on to the next problems, which are on page 907. All right, so you should be on page 907, and you should have already done problem 11A and B. If you didn't, pause it now and do them before you watch the rest. All right, so let's start with number 11. It says, use the line graph at the right here, and we'll zoom in on that in a second. Between which years did the winning time change the most? Explain. So let's zoom in on our graph and look for when it changed the most. So as I'm looking here, I look for the biggest increase or decrease, the longest line. And if you notice here, I'm going to highlight it. This section here, oops, that's the pen. Let me put on highlighter. This section here is the longest section of line. So there was the biggest change right there. Now, between which 2 years was it? Well, the first dot is at 1992, and the second dot was 1996. So our answer for A would be from 1992 to 1996. Now, it says explain. So here's what I would say. Okay, so I said the line between these years had the steepest drop. And that's how I know that's the biggest change, is because that is the steepest drop compared to these other ones. All right, so now, remember, you could pause the video and change your answer if you made a mistake. Make a prediction of the winning time in the 2020 Olympics. Explain your reasoning. So we're looking at the 2020 Olympics. Now, so far, the graph has up to 2008, and they have 2012, 2016, and the Olympics are every 4 years. So to make a prediction, I'll show you what I'm going to do. First off, I noticed that it looks like from pretty much 2000 to 2008, seems like there's a pretty consistent decline. That's like a straight line. So I'm going to continue that straight line down to 2020. Now I have to add another section here, so I have up to 2020. So I'll pause and do that. Okay, so here's what I did. Notice I kind of added some more grids to the right, and I added some more grids below. I tried to make them about the same size as the other grids. And I continued the numbering. I noticed that the numbers went down by half each time. So I went from 50, 49 and a half, 49, 48 and a half. And over here I have my years. This was 2008, 2012, 2016. And this next line here would be 2020. That's the year we need to worry about. So now to make my prediction, in this straight line here, I noticed that from this dot to this dot, it kind of goes down like a box and a half. See, this is a full box and then a half. Then from this to this, it kind of goes down another half and a box, so another box and a half. So I'm going to continue that by bringing this dot, I'm going to bring it down a box and a half right there. So I'll use a blue line here. So I think 2012 would probably be about there. And then 2016, I think it's going to go down another half and a box to right around here. So I'm going to continue that. Probably here. And if it continues with this trend, that would mean that I might need a little more grid here. Okay, it would go down another box and a half. So I'd have to go down another box and a half right about here. So if I continue that, I'm going to put a blue dot right about here. And that's 2020. Now to make my prediction, I notice if I go all the way over here, this is 48.5. If I went down to the next one, it would be 48. So somewhere around 48, and this is winning times in seconds. So my prediction is going to be, if I go back over to the right, it says make a prediction of the winning time in the 2020 Olympics. So I'm going to say 48 seconds. And now I'm going to explain my reasoning. Okay, so here's my explanation. I said I continued the line from 2000 to 2020. If the trend continues, the winning time will be about 48 seconds. So remember, if I go back over to show you, explain my explanation, notice right around here in 2000 is when this straight line started. So that's what I said. I continued the straight line from 2000 to 2020. And that's why I said the winning swim time should be about, this is 2020 over here, probably about 48 to 48 and a half seconds. Now, if you didn't have my answer, that's okay. I would say if you had an answer anywhere, say between, I don't know, 46 and 52 seconds. Or I'm sorry, not 46 and 52. If you had an answer between 46 and 50 seconds, not 52, I would say that your prediction was pretty good. Mine just came out to 48. All right, so that's it for this page. Now, we are going to be on to page 897. Okay, so here we are. We're on page 897. And on 897, I'll write that at the top so people can see it. Page 897. You had to do 10 and 11, so make sure these are done before you watch this video. Unless you don't understand it, you could always, I guess, do it with the video here. So I'm going to start with number 10. Now, in number 10, let me get rid of some of that ink. In number 10, it says, the box plot shows donations in dollars to charity. Describe the shape of the distribution. So let's take a look at this box plot, and we are going to describe the shape of the distribution. Okay, so let's take a look at our graph here. So it says donations to charity, and we have our box plot here, and notice the star with the outlier. Now, right here, I have the 5 words we use to describe data distributions. The thing is, maybe you have forgotten this, 3 of those words don't work with box plots. We cannot see gaps because we cannot see individual numbers. We cannot see peaks because we cannot see individual numbers. And we cannot see clusters. So your description here has to talk about whether it's symmetrical and whether there are outliers. So when I describe this, I'm going to say the data is not symmetrical because look at the left side is much smaller than the right side. So the data is not symmetrical, and there is an outlier at 220. So that's all I'm going to say for that one. So let me scroll back over. Okay, so describe the shape of the distribution. All right. Okay, so here's what I wrote. The data is not symmetrical since the right side is more spread out, and I wrote there is an outlier at 220. So make sure your explanation should be somewhat similar. You should have these 2 words in, and hopefully you had that one right. Okay, pause the video if you need to make corrections. Now, for number 11, they give us another line plot here. It says miles ran each week, and they're going to ask us to do something to this. So here's what it says. It says, the line plot shows the number of miles Elisa ran each week. Choose the appropriate measures to describe the center and the spread. Justify your response based on the shape. Then it says write a few sentences describing the center and spread of the distribution using the appropriate measures. Round to the nearest tenth if necessary. So basically in A, we have to choose the center and spread, and B, we have to find the center and spread. So to help us with that, I'm going to include a picture from page 893. So here is the table from, I think it's page 893, on choosing measure of center and spread. Now remember how you choose this. It's a flow chart. It says, is the data distribution symmetric? So take a look at this graph and decide, is it symmetric? And I noticed that it definitely is symmetric because look at the left is the same as the right. See those four? Four here, and that group in the middle. So it is definitely symmetric. That means, since it's symmetric, we are going to use mean and mean absolute deviation to describe the spread. So first thing we're going to answer is part A. So part A says, choose the appropriate measure to describe and justify your response. So what I'm going to write, I'm going to basically say, because the data is symmetric, we would use mean and mean absolute deviation, since that's what the chart said. That's all I'm going to say. Okay, so here's what I wrote. The data is symmetric, so you use mean for the center and mean absolute deviation for the spread. Okay, so pause it if you need to make a correction, but that's all you do for part A. Now part B says write a few sentences describing the center and spread of the distribution using the appropriate measures. Round to the nearest tenth if necessary. Now if you remember from the lesson on this, finding the mean and mean absolute deviation is not as difficult as you would think. So, for example, because the data is symmetrical, the left and the right are the same. Whenever that happens, that means the mean will happen to be the exact middle. So you don't have to add up everything and divide by how many x's there are. You know the mean will be in the middle. So I'm going to write that down here. The mean, just so I can write a sentence about it in a second, is 31. Now the mean absolute deviation is also not as difficult in this one. So remember the steps for mean absolute deviation. You have to first find the mean, which we did. It's 31. Then we're going to subtract each number from the mean, and then we're going to find the mean of those numbers. Now, reminder how easy it is to do that when you have symmetrical data. So the first thing I'm going to do, I'm going to erase this, and I'm going to write down my mean nice and big here for all to see. So remember, my mean is 31, and that's going to make it easier to subtract. Now, as I do this, remember, 31, I have to subtract each x from that 31, right? And each x in this first part are 31. So think about this. This is 0, 0, 0, 0, 0, 0. So then all those zeros add up to 0. Now, when I go to the 32, 32 minus 31 is 1. So each one of these x's is 1, 1, 1, 1. They add up to 4. And the left will be the same. 1, 1, 1, 1. They add up to 4. And then I go to the 33 and the 29. Now remember, 33 minus 31 is 2, so each one of these x's is 2, and 2 is 4. Same thing over here, 31 minus 29 is 2, 2 and 2 is 4. And the last I'll get the 34. So 34 minus the mean of 31 is 3, so each one of these is 3. And since it's symmetric, the left side, each one of these will be 3. And 3 and 3 is 6. Okay, so what I just did is I did step 2. I subtracted. That's all these numbers up here. And I actually started step 3, finding the mean of those numbers, by starting to add them up. So I have to finish adding them up here. So I know 6 plus 4 is 14, plus 0, plus 4 plus 4 plus 6 is 14. Remember, it's all symmetrical. So add that up, they add up to 28. But remember, to find the mean, I have to then divide by how many numbers I added. And remember, the numbers I added are all of the x's. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I'm going to take that 28 and divide it by 22 x's. And if I do that, I get 1.27 repeating. So put a bar over the 27. So that means my mean absolute deviation is 1.27. 27 is repeating. All right, but the last thing I had to do is, remember, it said write a few sentences describing the center and the spread of distribution using the appropriate measures. Round to the nearest tenth if necessary. So I guess I'll round that mean absolute deviation. So I'm just going to put these numbers in a quick short sentence. And here's what I said. I said the mean is 31, while the mean absolute deviation is 1.3, because I rounded that 1.27 to the nearest tenth place. All right, so that's it for number 11. Now we are moving on to the next page. We're moving back. The rest get quicker, don't worry. We're going to go to page 885. All right, so we're on page 885, and you had to do number 10 and 11. So for number 10, you had to draw a box plot, and number 11, you had to answer questions about the box plot. So let's start and see how you did in number 10. So the first thing I'm going to do to draw a box plot is I have to put these numbers in least to greatest order. So I'll pause and do that. Okay, so I have all of my numbers in least to greatest order here. And I have my 5 data points listed. The Q1, Q3, median, lower extreme, or the minimum, upper extreme, or the maximum. So I'm going to start by finding those. Now, the first thing I notice is there's 15 numbers, because I did 1, 2, 3, 4, 5 times 3. And if 15 is odd, there's going to be 1 in the middle. So that means I'm going to have 7 lower ones. Oops, I don't want to use the pen. Highlighter. So 1, 2, 3, 4, 5, 6, 7. And I'm going to have 7 upper ones. 1, 2, 3, 4, 5, 6, 7. And that leaves my middle of 67. So my median is 67. Now my lower extreme is 40 and my upper extreme is 81. They're quick. And Q1, well, I have my lower half of numbers here, and I have my upper half of numbers here. And since there's 7, there's only going to be 1 in the middle. So if I cross off little, big, little, big, little, big, I get 55 in the middle, which is Q1. Do the same on the right. Little, big, little, big, little, big. I get 77 in the middle, which is Q3. So now, what I have to do is I have to make my box plot. So I'm going to put dots at each of those numbers. I notice the numbers count by 5. So the lower extreme is 40. I'm going to put a dot above the 40. Q1 is 51, so that's going to be right about there. The median is 67, so that's going to be right about there. Q3 is 77, so that should be right about there. And the upper extreme is 81, so that's right about there. So I have my 5 dots. I'm going to draw my whiskers. And then I'm going to draw my box. And that's my box plot. All right, so now let's go down to problem 11. And in this one, we have to answer some questions about this box plot. So notice we have math scores, and it looks to me like the lowest grade was a 60. Hope that person retested. The highest grade was a 96. No hundreds, wow. So in A, it says, what was the greatest score? Well, here's our upper extreme. The greatest score was a 96. Now, the next part, B, says, explain why the median is not in the middle of the box. So here's what they're saying. You see how this line is median? Why is it not right here in the middle? Well, what that means is the right side of the data is closer together than the left side. So you can say the left side of the data is more spread out than the right side. So that's what I'm going to say. Okay, so I wrote the left side is more spread out than the right side. And if you look up here, that left is definitely more spread out than that right. Now C says, what percent of the scores were between 71 and 96? So I'm going to highlight those. So 71 is right here, and 96 is right here. So we need to figure out what percent of the scores were in this pink shaded section. So if you remember with box plots, each section is 25%, right? That's 25, 25, 25, 25. So if we put these together, that means that 75% of the data was between 71 and 96. And the last one is problem D. It says half of the scores were higher than what score? So when we're talking about half, that makes me think of the median. So half of the scores were higher than the median. So they were higher than 82%. That means half of the class had higher than 82, half of the class had lower than 82. All right, so that's it for this page. Now we are going to move on to the next page, which is page 877. So we're on page 877, and you had to do number 12 through 16, and guess what? 12 was already done for you, so no big deal. So we're going to start by doing 13 through 16, and all of our questions are going to be about this histogram here. So let's take a look at the first problem, which would be 13. Now problem 13 says, which interval represents the greatest number of players? So if I look here, I'm looking for the highest bar, and the interval would be 24 to 27. So that's your answer for 13. So 24 to 27. Okay, so the problem 14 says, which interval had 4 players? So let me go back over and zoom in. So I'm looking for the number of players, which would be the frequency. So I'm basically looking for which interval had 4 players. And if I go over, the ages interval of 28 to 31 had 4 players. So 28 to 31. Okay. Now, question 15 says, how many players are younger than 28? So let's go over at our bar graph. Younger than 28. So when I'm doing that, I like to find the 28, and I see it's right here. So that means right here is where 28 starts. So I am going to add up the bars that are younger than 28. So the first bar has 6 players, and the second bar has 11 players. And 6 plus 11 is 17. So our answer to number 15 is 17 players. And for number 16, how many players have ages in the interval 32 through 35? So let's go find the interval from 32 through 35, and that would be right here. And it says how many players have those ages. So if we go up, that would be 8 players. So the answer to 16 is 8 players. All right, so we're done with page 877. Told you that would be a quick one. And we're on to our last page, which is page 869. Okay, so on page 869, we just have to do number 13, and you should already have it done, so you should just be checking your answer. Now, the directions said to make a line plot, so we're going to make a line plot here. And then it says find the median, mode, range, and any outliers of the data shown in the line plot. Then describe the data using them. So you should have a couple sentences here basically giving me the median, mode, range, and any outliers. All right, so let's start with the line plot. All right, let me zoom in a little bit so we can see it a little bit better. And we'll start making it here. So I see, I'm going to count all of the zeros. So I see 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 zeros. That means there should be 8 X's or dots above 0. And then I'm going to get all of the ones. So I see there's 1, 2, 3, 4 ones. So that means you should have 4 X's above the 1. Okay, then I see a couple 2's. And then it looks like there's 1 6. And I am guessing there's a good shot that that 6 is an outlier, but I'm going to put it through the 3 steps anyway. So now, the next job is we have to write a sentence and we have to find the median, mode, range, outliers. So median, mode, range, and outliers. So let's start with the median. Now, when I count the numbers, I notice there's 3 times 5. So there's 15. So that means there should be one middle. So I'm going to go through and kind of mark off little, big, until I get to the middle. So I have little, big, little, big, little, big, little, big, little, big, little, big, little, big. And I found my one in the middle. So my median is going to be that red one right there, 0. My median is 0. Now the mode is also 0 because the mode occurs the most. And my range is the biggest number minus the smallest number. So 6 minus 0 is 6. So I already found 3 of the 4 things. Last thing I want to do is I want to find any outliers. So remember, to find the outliers, I think 6 might be an outlier, but you never know. I'm going to put it through the test. The first thing I need to do is find the interquartile range, which is going to be Q3 minus Q1. So let's focus on finding Q3. So I have little, big, little, big, little, big, middle. So Q1 is going to be 0. Now for Q3, I'm going to do the same thing on the right side of the data. So I'm going to start by crossing out little, big, little, big, little, big, and then I have 1 in the middle here at 1. So that means my Q3 is 1. So to get my interquartile range, I do 1 minus 0, which is 1. So I have an IQR of 1. Interesting. So the next part is I need to multiply that by 1.5. So I'm going to do 1 times 1.5, and I get 1.5. Remember, that is my boundary number. 3, I'm going to set my boundaries. Now remember, to get my lower boundary, I need to take my Q1, which is 0, and subtract 1.5, and I get negative 1.5. So my lower boundary is going to be over here. So there's no outliers on the left. I didn't think there would be. Now to get my upper boundary, I'm going to do Q3, which is 1, plus 1.5, which is 2.5. So my upper boundary is going to be at 2.5 right here. So remember, this is my house. Anything outside of the house is an outlier, so guess what? 6 is definitely an outlier. So now I'm going to go down, and I'm going to write that here, that 6 is an outlier. So I have my answer, and now I need to just write a couple sentences about this. I could probably get this done in 2 sentences, because I'm going to use 1 sentence for the median and mode and 1 sentence for the range and outliers. So here I go. All right, so see what you think. Remember, I said 2 sentences. The median and mode are both 0. 1 sentence done. The range is 6, and there is an outlier at 6. 2 sentences done. That's all I need. So if you have a couple sentences basically explaining these numbers, then you are able to get this one correct. All right, you are done with me. That's your Chapter 12 review. I hope it helped. Thanks for watching.